record. Okay, welcome back. October 21st. Just wanted to go over a couple more foundational concepts, um, maybe new to some, uh, not to others. And I wanted to pull up our first Jupyter notebook in Python. So I'll walk you through that. I want to do that in the third hour. And then I posted the assignment I was talking about business questions. Posted that. You can get to it by clicking on assignments, or it's in the foundations module along with all of my slide decks. It's called business questions problems. Um, okay, Dave. Okay, and chat's working. So if you need to um, jump in, hit the chat. If I don't see it and somebody else does, just let me know. Okay, so first topic I wanted to cover is the tools. Now, we talked about processes and people and roles and responsibilities and whatnot, but I wanted to go a little bit more into the tools of the trade that we'll be covering, as well as some emerging things, and it's a moving target. The software marketplace is fierce, and people, languages and tools are rising and falling all the time. So you just gotta kind of brace yourself and hold on for the ride, and do everything you can to stay current. So we'll talk about some mental tools, a little bit about statistics, and then the actual software packages that we'll be using, and that are used by virtually every analyst on the planet. So again, stop me if you see if you have questions, or if you want to inject anything. This is absolutely not something I made up or came to some sort of data-driven decision on. This is a few different articles I Googled out there, and they all made sense. It seemed to be what I had seen in folks that are just really good analysts, that you respect and admire and might want to model yourself after. So yeah, the first is you've got to want to know why. You've got to have a curiosity, inquisitiveness, and then I think it really helps to immediately, for your brain, whenever you hear something, some bold claim. It could be a commercial where they're the number one Toyota dealer in Arkansas. Well, what makes you number one? Who says what? Where's to get the data for that? So I think it helps to really have that mindset where you know virtually nothing is taken for granted, and you want to quantify, see what the data has to say. I think you got to love working with numbers, certainly solving problems. This is why I'm a part-time analyst. I'm not a mathematician. I don't love math, but I do what I need to do. But I think the best analysts out there, they really understand these concepts, like k nearest neighbors and cluster analysis. They actually understand the algorithm behind the statistical measures of significance and whatnot. So the more you love it, I think the better off you wind up in this field. I like this third bullet: intellectual balance and striving to avoid bias. That is something that is recognized in academic research, like, no kidding, peer-reviewed journal articles, so that you're more credible. but even in, I think in the business setting, for me, it was, a lot of military. When you're presenting data, it's important to just let the data speak for itself, and have some level of distance from the result, and so that you don't so that your audience, whether it's the, whatever, the board of directors, your boss, whatever, um, isn't thinking in the back of her mind, uh, this analyst is really trying to convince me of something, not not tell me what the data says. So yeah, just try and maintain that balance and professionalism. Persistent, boy, howdy. Particularly when, for me, dealing with coding, with writing custom code, Python being the one that comes to mind. Um, One little character, one little something weird can cause an error. I've worked as a programmer. I've worked um, hours on a line of code that wouldn't cooperate. So you really do got to just stick to it, and that curiosity. That everything's out on Google. There used to be you were kind of limited to manuals that came with the software and system, and if that didn't figure it out, you were in trouble. But now, if you're persistent with Googling, you've got all these websites out there, Stack Exchange, Geeks for Geeks, just and any number of them that are really informative. And then communicative, being able to present the results of the data, and working within that data analytics lifecycle, or that requirements analysis, where you can kind of put things in a different, in the audience's parlance, so that you're not going over their head maybe with technical jargon, and then listening and hearing things, and not being afraid to ask follow-on questions. That whole interactive cycle of communication, I think, really helps. So, of course, I need to ask someone, or three, or whoever would like to participate. What do you see that you admire in analysts that are perhaps uh, mentoring you, or somebody you look up to for advice and technical help?
Highly organized.
There you go. Again, I don't. I wish I were more organized. I don't know if I am or not. Well, everything's relative, but absolutely organized, methodical, um, and everything in its place. Who else?
You kind of already mentioned it with methodical, but yeah, just very procedural, methodical, because then the next person coming up along after you, or someone assisting you, um, will kind of know what's happening, what you're doing, and then it's your processes are able to be replicated.
Good, Leila. Yeah, the all of the maturity models that you see, software development comes to mind specifically for me, is repeatability, process repeatability. The steps are documented. In y'all's case, I know Jeremy keeps a data dictionary so that everybody knows what data is available, where it came from, what it means, what the different attributes are, um, the when it was pulled from a system, if it's not live. So yeah, documenting what you're doing, and um, I'll hammer on that a lot in Python. Commenting your code is the lowest level, and arguably most critical. Um, so that when you come back to it, or somebody else comes to it, it's repeatable. They know what you're doing. And okay, thank you for your participation. Okay, so this next one, statistics, which is really just the math. the math involved in data analysis. Um, but it's collecting, organizing, and interpreting the data. So you've got, you know, 10,000 numbers in a column. Well, what does that mean? And it depends. So that's where we'll get into it somewhat. But if you've never had statistics, and tell me again, who's the math major?
That would be me.
That Hunter?
Hunter, yeah.
Hunter. Okay. Oh, you did pop in. Good, buddy. Let me go back to the class.
Yeah.
And mark you here. And
Apologize for that.
no problem. It happens. It's much less, of an interruption when you pop into a Zoom session than it is in an actual classroom. So don't sweat it. And yeah, I'm gonna have to get with Wesley. I know he was in Power BI training Monday and Tuesday. Hopefully he's doing all right. Wesley works in the banking industry for like a contractor that works for, I don't remember which one, Arvest. Back to the presentation. So statistics fall into two basic categories, and Hunter, you're welcome to embellish on this, or anyone else that's recently had a refresher on it. I've had, Stats 101 as an undergrad and quantitative research methods in my doctoral program, and then constant brushing up because I have to talk about it. But I'm absolutely not a statistician. Though I know one. I'm trying to get her to come in and do a more advanced workshop for us. But they basically fall into two categories. Descriptive statistics takes the data that you have and explores it. And you can look at, this is where you look at the, if the min, mean, max, mode, range, all of those things of a particular data item or a particular attribute. But then it's also looking at how two attributes interrelate or correlate, or what relationship they might have, those sorts of things. But it's describing the characteristics of just the sample of data that you have, or the population, which is all the possible data for the, that makes sense, that's in that right domain. So inferential statistics, the other side, looks at if you have data that is not all the data, that's not exhaustive of what you could have collected, but it's a sample from a population. Say your population of study participants, the total population is adults from age 40 to 55, all adults in America from age 40 to 55. Well, that's millions of people. So you're not gonna actually ever get all that data. So, but you can take a large sample or a small sample, and then you can derive the trustworthiness of that sample and how much it, how well you can, what kind of confidence you can have that it actually reflects the true average, or whatever the case may be, of the population from which that sample is drawn. Anybody want to embellish on that, or is that a fair working working definition?
Yeah, I would say so. Descriptive really leads into inferential typically, but yeah.
Yes, it does. To me, you can't really understand inferential statistics until you look at describing a data attribute, an element, and its distribution, which leads, the whole normal curve, and we'll talk about that starting Tuesday. You can't do inferential statistics until you know the distribution and how probability theory works and the probability that an observation is going to be within the the bell curve and all that sort of stuff. So yeah, I mean, yeah, that they teach descriptive first in Stats 101 from what I remember, but then you use that as the foundation for what you need to know, the formulas and whatnot, to plug into for inferential statistics. And there's just, you can get a PhD in this. So so it's huge. And I have found now, this is the third time doing a course like this, uh, um, an apprenticeship course, not a college course, where it seems like at work there's just not a whole lot of inferential statistics going on. You're not trying to necessarily infer that we sampled 10% of our customer data. Now, what's the whatever the p-value and confidence interval and all that stuff for all of your customers? Generally speaking, people are using all the data they have, and that's it. But I could be wrong. There was even in the healthcare world, I don't remember a whole lot of true inferential statistics as far as like an experiment. Like the latest one that we've all heard about is these vaccine trials and the sample size, and we need more data because the sample size generally equates to a tighter confidence, a better confidence in your result. Okay, and the statistics. I have a buddy met in my time at UCA who he got through it, but he had a lot of trouble, and it's no kidding, it's complex. But he liked to call it statistics, and yeah, he was one of those guys that like to make up funny words. Man after my own heart. And then, of course, the next one, Microsoft Excel. Would anyone be safe to say that you've hardly seen Excel since whatever? Haven't seen it in years, with large exceptions, or is it?
I use it every day at my job.
Every day, yeah. And we'll get that in these classes, folks that are gurus, power users. But are any of you really not all that confident at all?
For me, it's more of a refresher. I used to use it extensively every day, but it's been years since I've had to do something like that.
Okay, Jim. And I think that happens. Aren't you? You're in a leadership role, are you not?
No, not yet.
That happens, particularly as you become a supervisor or whatever. You just don't have the time to put hands on. So we'll go through an intro refresher, and then I've got Mary Kate Sumner coming in for a 2-day ramp it up into intermediate Excel. But then, I mean, Excel is a powerful software platform. There are a lot of things that you can do with it that we won't get into. But I think you'll be refreshed with it enough, to do charts and pivot tables, summary data, that sort of stuff. Go ahead. No, I'm sorry. I thought somebody wanted to jump in there. So yeah, first released way back, 85. One of the first killer apps for the personal computer was the spreadsheet program. For sure, it was VisiCalc on Apple. It seemed like but that's before I even started working on computers. And depending on who you talk to, it can do almost anything. As far as analyzing data and reporting the results. But it's not necessarily the best at everything. So I think it's a great tool to have in your toolbox, but it isn't necessarily the only tool to have. Yeah, over the years, 17 billion, 179 million individual cells in a spreadsheet. The largest I've ever messed around with, I was helping a former student, and it was 11,000 rows, which is cumbersome, moving around that and everything. But there are much larger. So, Paul, you use this every day. What size of number of rows and columns are you seeing on the outer extreme?
Just the other day, I spent the entire day cleaning up over 70,000 rows of bad data.
70,000 rows. Yeah. Yep. That's pretty big. And
But we're troubleshooting a tool that a developer just built for us, so that should not be an issue anymore.
there you go. So you were basically software testing, really testing the output.
No, I was just trying to get some numbers to our sales team so they could get commissions.
Oh, but you had to compensate for
Yeah,
issues.
a previous tool that we were using is just broken, so we've recruited a new developer to make a new tool for us.
There you go. But we still see this and working with it, employers like we did with all of yours, or we do with all of yours. You still see Excel. I mean, it's absolutely the go-to data analyst tool, and folks still want you to know it. There's alternatives. There's Google Sheets, and LibreOffice has a version of it. There's Excel Online, web-based version of Excel, but good old Excel desktop version and a powerful PC, still really useful. So like I think I mentioned, if my audio was working on Tuesday, you can do an entire, like, almost like a database data entry application thing with Excel, but that often stretches what it's good for, and depending on the level of expertise and everything, it can get folks into trouble. So we're just going to work with tabular data in worksheets, and formulas and functions and pivot tables and whatnot, sorting, filtering, those sort of things, and built-in charts. So Paul, I do apologize. You probably won't learn a thing.
That's fine. I still don't know a lot about Excel. I know very basic stuff, but that seems to be enough to get me by.
All right. Well, as we're going through this, I know you want to be polite and everything, but if there's something cool that you'd like to, that you Excel power users would like to accent on, please do so. For example, last class, I didn't specifically mention paste special, and pasting just the values, instead of, like, if you've got some complex formula and you copy that column and paste it, by default it copies the formula and all that stuff, not the numbers that you see. And somebody jumped in and said, hey, don't forget to cover paste special. So things like that, if we skip it, feel free to jump in, particularly once we've done my little intro spiel and the intermediate workshop in week 4. If you still feel like there's any of y'all feel like there's gaps of something that you wanted covered, just shoot me an email, and I'll brush up on it, cover it, find somebody that knows it, whatever I have to do to get that going. So that's Excel. Tabular data, we've all seen it, X and Y, columns and rows. And since you've seen that, even if you've never seen SQL, and you'll hear sometimes it pronounced SQL. I particularly have an annoying habit of bouncing back and forth between these pronunciations. Generally speaking, folks that work in the database world call it SQL. And but like I said, I will I will slip back and forth between the two. So SQL's been around since '86. and it is generally it is the language for working within what's called a relational database management system, which you might have heard of Oracle. There's SQL Server on the IBM DB2. And then on the open source side, the free side, you've got MySQL and MariaDB and Postgres, which is actually spelled PostgreSQL. So all of these fill basically the same need, and that is to store data. And we'll go over this in great detail here in starting week 5. To store data in relational form, and really, it's really not that complicated. It's like a spreadsheet, but all the spreadsheets are linked together with what are called keys. You'll hear the term primary key and foreign key, and it keeps you from repeating the data unnecessarily, and gets it in the correct format for a relational database. But SQL is basically the language that you use kind of to do everything you need to do in the database. So it's a query language. It allows you to pull columns of data based on some criteria. It's very English language sounding. But you can also find a specific answer to a specific question where you get one number or one name back out of the database, and everything in between. And we'll spend a couple of weeks doing beginning and intermediate SQL queries for those reasons, answering business questions and drawing data that you can then pull into some other tool. But SQL can also be it's called structured query language, but it's also a data definition language. You also use SQL to define a table, the actual like work spreadsheets, and what columns and any constraints on those columns. You can insert, update, delete data manipulation language, data control language. I think that's generally where you put like user permissions, who can see what objects in the database, who can see what tables and things like that. And then transaction control language, we won't deal with that at all. But if you're an application developer, and you're actually working with an application that puts data into the database and pulls it back out and back and forth and is dealing with database transactions, that's where you would like do a commit statement to save a change to the database or roll back a change to the database. So it does all of those things. SQL does all those things, but we will be focusing on using it as a query language because that's our reason for being here as data analysts. And these slides I've put links in a lot of the speaker notes. So here's another one that goes into more detail on what those different functions of SQL are. And then we got good old Python. Now I wasn't really even paying attention. I was working on enterprise level stuff, and Python just snuck right up on me. But it's an awesome general purpose language. People are writing games with it. It's being used on the back end of web applications to control the business logic of an application. All kinds of different data analysis. It's taken off like crazy. So this is, I think, generally the language in Arkansas that the schools are using to teach kids programming as early as elementary school. And I've seen some high school kids. Like I said, we sponsored a hackathon at UCA in 2020, February 2020, and some of these high school kids are just awesome, way ahead of where we were, back in the day. So it's good to see folks getting good computer science education. But it is an open source project. It doesn't cost anything, like maybe back in the day Microsoft Visual C++ would have cost you $100 or whatever. First released in 90, but I didn't start hearing about it until more like the last 10 years. Some of you are computer science folks, so you know what an object-oriented language is, and you know what object-oriented concepts are. Python is an object-oriented language, but what we'll be doing doesn't require creating classes and methods and whatnot. But as we move through, for those of you who have no idea what I'm talking about, you'll learn a little bit about what that means. What does it mean to be object oriented? Because your data, your variables, your things you're working with, are objects, would have methods, and we'll get into it in Python. So there you go. It is an object-oriented language, but we won't be writing any or declaring any of our own classes. And the real, beg your pardon. So they say out there in the Python community, the real impetus for the growth is the libraries, the work that the open source community has gone to add additional functionality beyond the basic language. If you loaded up everything that Python can do into one Python session, it might like just crash your PC. There's so much functionality out there that you only pull in these libraries, which is just a set of functionality. And like I said, we'll spend lots of time on this. You only pull in what you need to keep from bogging down your system, because you've got this monstrous, gigantic Python program running. But that's really the particularly from what I understand, pandas and its subordinate libraries. Pandas is a way to work with easy way to work with data, so that it kind of looks like an Excel spreadsheet, and you're able to do a lot of the stuff that you would do with a mouse click in Excel, you can do with a line of code in Python. But like I said, much more to follow on that. But then from Stack Overflow, if you look at it, they mine the query data. You can kind of see the rise of Python from this chart goes from 12 to 18, and it's the increase in queries on that language. And good old Java, which is the I don't know, the foundation of most of the internet applications that we use, is pretty steady, pretty steady at the top. There's a whole lot of Java jobs out there. C# does a lot of the same functionality. That's what that C #, that's actually called C#. JavaScript is one of the languages, the big three tools that you need to learn to do front end web page development, but it's being used in a lot of other areas. So it stays pretty popular and is creeping up past Java. There are, I don't know if you guys are programmers, web developers, there's pure JavaScript stacks out there now that are gaining in popularity. And then we have the choice of real data scientists and pirates. Like I said, the statisticians, mathematicians, physics scientists. What do you call not a physician? What do you call a physics guy?
Physicist.
A physicist. That's it. A physicist. Physicists. I got a buddy at UCA that does like a half an hour TED talk on analyzing audio data with a Python library that reaches into the data and does digital signal analysis. Yeah, it's just fantastic. Lots of folks using it, but it's very specialized. Hence, its limited applicability and limited growth in popularity. I don't know that Python will ever supersede R, or in the near foreseeable future. I don't know that Python's ever going to unseat R among scientists. But it's gaining in such popularity that I know like at UCA they're moving their business analysis programming content or curriculum from R to Python because of the growing popularity of Python. So there you go. And it is also open source. It's free, and like Python, it's got libraries that you can pull in. And yeah, the syntax, I don't know if you guys have seen both languages. It's not as intuitive. To me, it's just not as understandable and readable and everything as Python. For example, the assignment operator, if you wanted to declare, my underscore name equals Don, that's what it would look like in Python. My underscore name equals Don. But in R, they use like the dash and the greater than sign, like this value goes into this thing. I don't know. It's just hoinky. I'm just not a big fan, but there you go. It is in the analysis world a big tool. Are any of you guys, around R programmers?
I've played around with it. It's not my favorite.
Are like are any of you in your organization that you know of around R programmers?
No, but I'm about to start a project where my CTO wants me to learn it.
Okay. Well, there's all the resources under the sun out there on it. I just not to belabor, or if you don't want to get into it, I understand, but why doing the project in R versus Python?
I'm guessing it's because that's what he's familiar with.
Yeah, could be. And that,
Sorry, go ahead.
no, that's you got to make a decision as a manager, and that's absolutely a rational one. If you're going to have to mentor and support an effort, and it's R is absolutely the scientific analysis language. I don't know. It's almost you get into you love what you're familiar with. So R programmers love R for data analysis, and Python programmers love Python for data analysis. So you get into that, the tabs versus spaces tribal aspect. But I'm curious if there's anything that R can do that Python can't. And I thought I had seen some studies that Python's a little faster at executing.
I have seen a cohort in my current master's program. They're making us use Python in the graduate program, but he used R for his project, and he was able to do a lot more robust predictive analysis than anybody else. So I don't know if that's a particular feature of R or not.
I don't know, or if it's a matter of knowledge. Yeah, I mean, a better R programmer is going to be able to figure stuff out better than an intermediate Python programmer. So I don't know. The only study I remember seeing was on execution speed, and I think Python was a little bit faster. But anyway, it doesn't really matter. What matters is that the team uses them, and it's repeatable, and you've got good training, and the code is reusable, and the way it's applied is is accurate, all those sort of things. So then we've got visualization tools, which tends to be the way you present this analysis to its final consumer, normally some sort of decision maker. And that's where you start to make sure you've got things where they make sense. The scale of all the things looks right and it's readable. And some major tools in this segment are Power BI from Microsoft, Tableau from Salesforce, but then SAP, statistical analysis software, SAS is still out there. Google Data Studio. I think I've been pelted with one. I think it's Yellowfin BI, because I do a lot of Google searching on technical stuff. My YouTube ads are all Google career certificates and all kinds of Code Academy, this and that. So I've seen Yellowfin BI. They're putting a lot of money behind advertising. I don't know who's behind it, but depending on which Gartner poll that comes out, Tableau is a market leader in this segment.
Hey,
Sure, come on.
don't eat that just yet. I'm gonna cook you some sausage with that.
Okay.
Yeah, because if you don't, you're gonna want a snack in an hour.
Oops.
Sorry.
That's all right. I think we've all gotten to know each other just a little bit better during COVID with all of these video sessions.
Right.
Data. So yeah, Tableau is a market leader, arguably. I'd waffle back and forth between these because I don't use any of them daily. Just for for teaching this course and out of my own curiosity. Although Salesforce is such a high paying niche, I've been really tempted to do some tech refresh in that area. But then you can do Excel, Python, R. You can tell a data visualization story in both table format and charts and graphs and whatnot, using Excel, Python, R, or I'm losing my train of thought. There was one other that I wanted to throw out there. Oh, or Python with embedded graphics that you've generated in Python. I'm sorry, PowerPoint with graphics that you've embedded and created with Python or Excel. So there's any way to tell this story. There's so many different ways to present your results. It's really up to your choice and your team's choice. So as we said, which tool is best? You'll see. I've been in a Python class thinking, working with a data frame, which looks like a spreadsheet, thinking, oh, good grief, let's just go back out to to SQL, whatever it was that generated this thing, and let's write the SQL query better rather than wrangling it in Python, because it would have been better to do the processing in that language before you got to the next language. So you'll see there are, which tool is best. There are people out there that use R like you or I might use Excel. They're just that good at it. So they can just type away and code things up, particularly in a Jupyter notebook. And we'll see those here before we leave this morning. There are folks that, there's just your comfort level. So it just all kind of depends. Like you can, I'm sure you've at least heard of a pivot table, which is a way to kind of summarize data for a given repeating field. You can pivot data in Excel. You can pivot or group data in SQL. You can pivot a pandas data frame in Python or R. So it just, there's common functionality. It's just a matter of your team and what you need to accomplish and what you feel is best for the job. So we're running a little long here. I like to break at the 15 for 15 minutes. So what I will do is not bug you guys to come off mute and talk about this, but I'll leave this screen up here, and this is kind of the basis of the assignment that I talked about doing today. Business questions and the data, the underlying data landscape where you work, so I can get a better idea of what you guys are working on. So any questions and feedback? Has my audio been rock solid?
Seems to be. I've heard you the whole time.
The whole time. Awesome, because that is too stressful for words when you're trying to get something done with a group of people and you feel like you're wasting their time. It just bugs the heck out of me. Okay. All right, guys. It's 9:20. Let's reconvene at 9:35 cell phone time. We're going to talk a little bit about data, and then I'm gonna launch into some Python, and then we'll be done for the day. So 9:35 reconvene. Okay, welcome back, y'all. Just had one more piece of PowerPoint I wanted to discuss, and then we will do a tour of Jupyter Notebook and Python, and get you to write if it's your first Python program, get you to write your first Python program, or execute your first line of Python code anyway. Okay, so I wanted to getting gradually down into the weeds. I wanted to talk about data itself, the actual meat of the subject. Sources of data, where data comes from, and this is not exhaustive whatsoever. They're functional area support systems. These are the actual systems that support your finance or support your HR or your marketing, or production control or inventory control or whatever the case may be. We wind up getting data sometimes directly from them. And then you've got custom off-the-shelf corporate databases, corporate applications, and a data warehouse. Hopefully my audio was working on Tuesday. A data warehouse is really a place to put data for analysis, so that you're not writing queries that could potentially impact the performance of your actual transaction systems out there. Generally speaking, data warehouses are refreshed offline, off-peak business hours, so it doesn't affect those other systems. Then there's government websites galore. There's Bureau of Labor Statistics is fantastic for putting things out there, but the Census Bureau, there's just any number of because of it's your tax dollars paying for that data. Unless it's classified for some reason, there are robust and the most accurate, neutral source of data. There are commercial providers out there. I know some folks I've worked with pay for marketing data, and I know I don't think any of you are. Correct me if I'm wrong, but I don't. There are folks that are in the data providing business. I know we've got quite a few folks at Merkle in the old Arkansas Democrat Gazette building, and they that team works on those, you know, those direct mail campaigns for that mailbox full of credit card, house refinancing, and whatnot. So there's algorithms, you know, that they use to identify you as a person and market to you so that, you know, they're not wasting money. Axiom was huge in the providing data to companies. Got a buddy there I know that has a huge account with Toyota. And then, of course, you've got, you know, academic and research institutions, a good source of data. And this can be like if you need to do like a background study for work. Pew Research is huge, but then you've got, you know, Gartner, and you can go get the actual. A lot of times, you can go get the actual data from these research institutions. And then I don't know if any of you are pulling in. We've got some folks working at like manufacturing plants. There's a company called Hytrol in Northeast Arkansas that makes those massive conveyor systems, like at a Amazon fulfillment center. And in a manufacturing facility, you've got any number of IoT devices, sensors, as well as, you know, your network devices within an enterprise, servers pumping out from, you know, providing different services, network services, workstations, routers, you name it. There's just huge source of data, firewalls, proxy servers. One website that will probably keep coming up if you're you know, learning and teaching yourself more and more about analytics is Kaggle.com, and they have like competitions or exhibitions almost of they'll post a data set out there and ask some different questions, and people will post. You frequently see Jupyter notebooks, which have the documentation of what they're doing and why, and the code itself, and it's out there on Kaggle.com for you, and then it makes for great examples, great code. And then DIY. I'm going through this right now. We've got a customer relationship management software that we use to keep track of all of our corporate contacts that we work with, you know, your employers and you guys as apprentices and our training partners and whatnot. And we're having to go in and do a fair amount of customization because nothing generally, you know, works perfectly off the shelf. So you got to go in and add your own data fields, add your own data, go grab your own data. And particularly if you ever move on to a doctorate, you have to basically collect new data, whether it's survey or interviews or whatever. So I've added a couple of links down there in the speaker notes. So those are typically sources of data. I've asked you a sub question in that little exercise today about the data landscape, and this is the kind of stuff I'm talking about. Where is your data coming from, and what tools? The previous hour, what tools are you using? So you can just get a little better understanding of what you guys are dealing with. So data formats. This is I wanted to approach this in two layers of, you know, what a data format might be. This first slide. Most of what we'll be working with in this course, virtually everything is pretty standard. Flat files, they call them that because it's a X, Y, and then columns, and there's no hierarchy or hierarchical organization to the data. It's each row is basically co-equal, and those can be comma separated values. CSV, which you see a whole lot in Excel. Your Windows by default will use, even though it is just a text file, Windows generally defaults to pulling up using Excel to pull up a CSV file. And so I always try to, if I know it's a CSV that I'm pulling up, I always try and save what I'm doing, pull it up, and then save what I'm doing as an XLS so that I don't goof up the source data. But then that's just a way to, comma separated values are just a way to separate, the last name column from the first name column from the age or whatever the case may be. They're all separated with a comma. And that can cause issues if you've got a comma where you don't want it. It can goof up the whole thing. And generally speaking, a comma separated a CSV file has, the first row will be the headers, the names of the columns. And then you also have tab delimited. I had to do some work with fixed length format to comply with our state government. When I was at UCA, to report for grants, like, whatever, or Arkansas Bright Futures, where you get, $1,000 to go to college, whatever it is. As an institution, we had to report that to the state to get our money. And that was in the format of a fixed length file. So like 20, you got 20 characters for last name. And if your last name's longer than 20 characters, sorry, that's what you get. You get 20 characters. And then however many characters for first name, and on and on and on. And then the software that's using that's processing that data grabs literally those numbers of characters and turns them into whatever they want. So you do see these different formats out there still. And of course, XLS is the kind of the de facto standard, an actual Excel worksheet. So those are flat files. And then these next two are kind of next level. You might have heard of XML, extensible markup language, and JSON stands for JavaScript Object Notation. These are they're text files. They're readable. You can pull them up in Notepad or whatever and look at them. But they tend to be a key and a value, like name Don Walker, and then age 57, and then whatever. So there's a label for the data. So you have, and that's called the key, and then the data itself is the value. And XML and JSON, I'm not a web developer, but those folks know the pros and cons of both. It seems like everybody's moving to JSON. But XML is a kind of a universal standard, but it seems like JSON is taking over. They're very similar in what they do for you. Anybody here work with XML and JSON? Want to extend what I've thrown out there? Okay. Like I said, you'll see that a lot in web applications. Generally speaking, when your computer is talking to a database across the internet, the data that shows up on your web page came to your computer as a JSON file, and then the web page itself puts it on the screen and makes it pretty and whatnot. So that's another format of data file. Relational data, we talked about that when we were talking about SQL, and it's a particular format for data that we will get into in week 5. I won't belabor the point now. And then you'll hear, particularly in discussions of big data, you'll hear about unstructured data, and that is just like what it sounds like, just raw text with no particular format, like a Word document or a text document, free form, or the actual text within maybe like a Google review or a social media post. Now that data comes out of like Facebook. If you grab Facebook data, it comes out as structured data, but inside of the post, it's just free form English, or it could be images, which are raw. They need to be, unstructured. They need to be analyzed for what it is you're trying to find in the imagery or the video. APIs are, stands for Application Programming Interface. And that is a sort of just a standard, a standard methodology whereby you can request and get data from could be a database, sort of, could be an application like Salesforce. You'll hear about all of these software as a service, subscription-based packages having, you can access the data via an API. And later in the course, I'll show you a Python program that uses Google reviews. You send it I think it's called the location ID. Google has its own key value for every building, every object in Google Maps, pretty much. And you can request all the reviews for that location object, and it comes to you, I think basically as an XML or JSON file, which is kind of convoluted that you have to do some processing with. But that's what an API does. It allows you to grab data from a data source, not necessarily using the interface that is primary to get into that data. Like Google Maps is kind of the primary way of seeing a review for something, or at least Google's websites. But if you want to process that data for any other reason, you can access that API, and we'll go into that a little bit more. It's kind of advanced. I don't know. You guys, I'm sure I'll learn from you if it's advanced or not. And then I did want to make a note about data types, which we've been talking about data formats here. It's kind of like a file format, like the whole data set. But in virtually all of these software tools, the type of the data type tells the computer how to store it and what and how to process it, and the software will treat the data item differently based on its type. And you'll hear things like, binary, it's either a 1 or a 0. It could be a numeric data type. A string is just characters. They can be numbers, they can be alphabetic. But it's just a group of characters. Date time data types, to me, are the toughest to work with. And you'll hear me say this again, probably more than you'd like to. Date times, because every computer at the chip level, at the hardware level, handles time and dates differently. They tend to be, I don't know, the twitchiest, most sensitive, error, hardest to work with data type out there. That's just kind of my observation, though. And then there's, at the actual observation level, there are different categories of data. The three primary here, and really the top, these two, categorical and numerical. Whenever you're working with stats or a visualization or a graph type or whatever, whether you're dealing with categorical data or you're dealing with numerical data will come up a lot. And categorical data is, putting something in a category: smoker, non-smoker, age group, binned in, 0 to 10 years old, 11 to 20 years old, that sort of thing. So you're categorizing whatever the observation is. And those can be either nominal, which means there's no particular order or no particular importance, like, I don't know, maybe car color, they're just categories. One isn't some more, isn't more important than the other. But then you've got ordinal categories, like maybe like a grade, a final grade, A, B, C, D, E, that sort of thing, where the order of the category matters. And then you've got numerical data. Discrete is like, and Hunter, jump in and correct me here if I'm wrong. Discrete is like, it's either 1 or it's 0 or it's 2. Continuous data, even though it's got to be represented by a limited number of of decimal places, continuous data is what you would think. It's a continuum of values from whatever to whatever. Does that sound right?
Yeah, essentially it's a density issue, density difference. Between two, there's not always going to be a data point essentially between two discrete data points, but there should always be at least theoretically, out to some number of decimal points, a value of a continuous data point between any two continuous data points.
There you go. Got it. Like, I think this is an accurate example, like a Likert scale, where you have from 1 to 5, completely disagree, completely agree, strongly agree. They are either a 1 or a 2 or a 3. You can only answer a discrete numerical answer, but you can average those. So you start to get, but there's no, the problem with survey data, and the folks at CA, this because they work with the student aircrew surveys a lot. The problem with the survey is that there's no hard and fast rule is what's between somewhat agree and strongly agree. What is it in your brain that makes you click on the 5 versus the 4 versus the 3? So that's where it can be a little tough to work with survey data like that, but that's its own whole specialty. But then I put date time. I'm pretty sure this would jive with the computer science educators. That is it's another category of data. And there may be others, but I think this basically covers everything we'll be dealing with. This probably doesn't handle like, name. What would like just a string attribute. Okay, so again, I won't belabor this, but I have asked these sort of questions in the assignment for today. If you just as much detail as you care to type out, I'd love to read about what you're working on and what your goals are and everything, and the data landscape, the tools you're using, all those sort of things. So you'll see, like I said, that's those sort of questions in the assignment today. Okay, so let's get started with Python. Let me put this stuff away. It's amazing how dry you get talking. Okay. So I need to share my whole screen here. Share screen. Put that away. Okay. So after you installed Anaconda Python, I know somebody was Jim, was it you asked me about how to run Python?
That's correct.
Okay.
It's getting a little, I'm just used to having, hey, get Python. I see Python. So,
Yeah. And I think you can, but generally there wouldn't be a like a start menu thing you can click on. But it would be, you can load Python and it will be like a shell command. Like if you bring up a command screen and you can say Python and then the file name, and it will run a Python script.
Okay,
But
makes sense.
we're going to be using Jupyter Notebook. So everybody installed, everybody's got, go ahead and mute, Jim. There we go. I think that's Hampton. Hey, Hampton. There we go. Thank you. Okay, so you installed Anaconda Python and it put a folder called Anaconda on your start menu. And if this didn't happen for you or you're having trouble or whatever, please shoot me an email and we'll set up a time, go offline, and I'll do everything I can to help you, and we'll figure something out one way or the other. But these are all pretty much default options. I have not really modified, my Python environment per se. So the first thing I would like you to do is pull up Jupyter Notebook. You should have a link here with that little orange thing that is Jupyter Notebook. This is a programming environment, and you'll see what I'm getting at here in a minute. So I use Chrome. What Jupyter Notebook will do is pull up a new tab in your browser. I like using Chrome, but it works with other browsers.
Mine pulled up a terminal.
When you clicked on Jupyter Notebook.
Yes.
Well, do you have Chrome loaded?
Yes.
Do you have it up?
Yes.
And it didn't open a tab. It opened the terminal.
Yes. Oh wait, I have a tab also now. Sorry.
Ah, there you go. Oh yeah. Yes, it will. When you first click on it, depending on how fast your PC is, the Python kernel, it's called, will show up in a black window, and then it will disappear. It'll go down to the taskbar, and then you'll have a tab. Okay. Okay, so now I'm going over to Chrome. I clicked on Jupyter Notebook, and it brought up a new tab. And I have down here at the bottom, you can see I've got this Jupyter Notebook. That is the Python interpreter, the thing that reads your Python commands and executes the Python. That's how one way to get to Python is through a Jupyter Notebook. Okay, so when you first run Jupyter Notebook, what you're looking at is called the Explorer window. This tab should look exactly like if you just pull up Windows Explorer by default. It should be the same folder structure, and it is. It is the same folder structure that Explorer uses. Okay, so what I need you to do And this can be, I need you to create a Python folder, and under Python, create one that's called notebooks. Now for me, my Python folder is on my OneDrive documents. So I'm just clicking down like you normally would on a, on Explorer. And here's my Python directory. This is where I put all my Python stuff. And the reason I'm asking you to do a particular directory structure is because all of my lessons count on you having a notebooks folder and a data folder at the same level. So inside of my Python directory, and again, this is exactly the same as it would be out on the hard drive, but you can create folders and whatnot in this Explorer window. So we'll do it here. But can everybody see I got my notebooks folder and then some tutorials and whatnot. I need you to have a notebooks folder, which you can create. Get rid of that view by clicking on new. Once you let's go back up under documents, you can say new folder, or you could do this with Explorer. So create a folder I call it Python, and then navigate to it and do another new folder, notebooks.
So our data and our notebooks folders are inside of our Python folder?
That's what I would, yeah. And again, this is, just basic Windows file management. Regardless of where you put it, I need the notebooks that I'll be providing to you are a single file with a .ipynb extension, IPython notebook. I need those to go in a subfolder. It doesn't even have to be called notebooks. Actually, it's the data folder is the one that will crash, that'll error if you don't have it named the same. But I need you to have a place to put these Python notebook files, and at the same level as I have this data directory here. So that's
Okay.
what I need. Everybody, you tracking?
Is this supposed to produce a dialog box to make a new folder? Because nothing happens when I click new folder.
Okay, let me new folder. Untitled folder. And then you click on it.
Yeah, nothing's happening whenever so I'm clicking on the new drop down,
Yeah, okay.
clicking folder, and nothing happens.
So just use Explorer. Just disregard what I'm trying to do here in this Explorer window. Use your actual, your actual Windows Explorer. And
Right.
here's the same folders. There's my Python folder, same. And in Python, I've got notebooks and data. So I apologize for the poorly practiced demo.
Second.
Okay. Okay. So somewhere in your, in your hard drive, whatever, under your My Documents, wherever you want to put it, you need a Python folder, and under that, a notebooks and a data folder. Now, if you're ready to proceed, I don't want to lose anybody. If you're ready to proceed, give me a thumbs up. In the reactions. Okay, Jim's good. Good, good, good. They tend to fade out. So I'm going to go ahead and move to the next step, because I'd like for you to pull up this notebook. The next step is to download, go to the classroom and go to the modules. And download this '01 Intro to Python and Notebook. This is the extension IPYNB. So click on that, should go to your downloads. Somebody let me know if that's not true. And put that in your notebooks directory you just created.
The one on the desktop or the one in Jupyter? Or both?
It will be the same. It'll be the same.
So it'll link. Okay, I missed that. Sorry.
Yep, that's all right. It'll be this. If you got a Python directory somewhere, could be on your desktop, could be under your My Documents, doesn't matter. Got a Python directory somewhere. Under that, you got a notebooks directory. Put this '01 Intro to Python and Notebook in that notebooks directory. You got it, whatever, drag and drop it from your, it went to your downloads, right? When you clicked on it, like any file on the internet.
Yeah, it did.
Okay.
Yep.
Download. There we go. Okay. So I'll hold off talking for just a minute, let you guys get that dropped into your notebooks folder. Okay. So like I said, when you first run Jupyter Notebook, it pulls up the default root directory that your Windows Explorer does. So however you do it, navigate to your notebooks directory in your Jupyter Notebook, your tab, your browser tab, like I've got here. So mine is in OneDrive, Documents, Python, Notebooks. And that's where I keep all of my notebooks. And like I said, the code and programming exercises and whatnot that I use often refer to a data directory that is up one level and then down into a data directory. So to avoid confusion, it's best to have that. You're not going to need that today. Okay, so this tab, when it first comes up, is the Explorer window. You're not really working with a Jupyter notebook until you click on a Jupyter notebook. So go ahead and click on that, and it will bring up another tab. And this is a Jupyter notebook. Like I said, we're going to be spending a lot of time with these. So I mean, if I'm unclear or you have questions, we need to come back to something. We certainly can. Okay, so this looks like a web page, right? Like it's out on the internet, but it is not. It is. It's on your workstation, and it's rendered through the magic, from that IPYNB instead of like an HTML file, that you can open. It's rendered because you've got this Jupyter Notebook environment installed on your computer. So it brings up that IPYNB file which has your document cells, which are called markdown cells, and then it has your actual code that can actually do something in these inside of that IPYNB file. So what you're seeing at first here is a pretty documentation, a set of documentation cells, or these markdown cells. There's just like, you remember learning HTML where you got the tags and all that kind of stuff. There's a language, a markdown language format that lets you do some really cool stuff. You can do like kind of complex mathematical formulas, and it looks like a graphic, but it's not. It's actually in markdown language. So if you double click on this first area here, this is for every Jupyter notebook is divided into cells. So double click on that, and you'll see it turns into the actual markdown scripting language. So this pound sign and a space lets the Jupyter notebook know that it's a header. And I'll post a cheat sheet on there. There's all kinds of cool formatting commands to get these markdown cells to look like you want them to. And then the other thing to look at is this drop down right here. You can tell if it's a markdown cell or a code cell because they operate differently. A markdown cell is just for documentation. A code cell will actually try and execute your Python code. So we know we're in a markdown cell because that says markdown right there. So if you want to execute the markup language after you've written it, you click this run button right here, and that's like running a computer program, but it's running the markdown language, and it converts it right back to that pretty stuff. So yeah, I covered folder and file coverage. We'll go a little bit into standards, but I really just want to just kind of introduce you guys to this environment and get you to write a line of Python code. Yeah, we'll get into this later. Minimally sufficient pandas is sort of like I know data analysis with Python enough to get by. Okay, so that's what you're looking at here. This is a web page. You can scroll up and down it just like you can any other web page. It's a really once you start looking for these things out on the internet, they're everywhere, as far as documenting analysis. And they don't just work with Python, they work with R, and I think there's ways to integrate other programming languages into Jupyter Notebook as well. But it's really convenient because all you need to send somebody is your IPYNB. So when I do a coding brain teaser exercise, you will just upload your notebook file, which is out there on the hard drive, just like any other file. Okay, so there's 3 types of cells. See this blue line? That's all one cell, all of that text in there. There's code, which actually executes and will do something. There's markdown, which lets you use different font sizes and font types and italics and any of that kind of formatting stuff to document your program, basically, or your project, your analysis project. We're only going to use code and markdown. I don't even know I've never had to work with NVC raw convert. I do need to give credit where credit's due. These notebooks I've modified them a little bit, but they're developed by Dr. Mike Ellis at the University of Central Arkansas College of Business. And so I get him to come in and do a couple of guest speaker engagements. So using his curriculum really helps me let him know what we've been able to cover by the time those guest speaker sessions come on. Okay, so there are commands to work with a cell. Like if you double click on this one, you'll see the source code basically, and you can see these numeric lists are it's just magic. It knows when you do 1, 2, and 3 to make a numeric list, and then to turn it back into pretty markdown, you just click on run again. So a cell, there's no limit to the number of lines of Python code in a code cell or the size of a markdown cell. There's no limit. And then, but if you do modify it, you have to run it, just like we did there. Let me see if I can change something. A couple of important things about, and I wanted to change it, and I say these cells in general. In order to see that change, you have to run it again, just like you would a computer. And there it is, these cells. Okay, so like I said, there's a whole syntax for this markdown language, and I can provide it. Generally speaking, for these assignments, I'm not asking you to be fancy with markdown cells. In fact, I can't think of anything that I ask you to do that isn't in code cells. And in that case, you can we'll see here in just a minute. Well, you can put a comment in there. So these are some things you can do with a markdown cell. You can bold text, bold italics. Oh, I think that's an error. Underscore italics underscore. That should be in italics. So let's see what's wrong with that markdown cell. It seems like it's got to be 2. But you can add bold text, italics. It seems like it's got to be 2. But anyway, that's the kind of thing you see that's an error in markdown. Here we go. Like if you want is in italics, if you underscore want, I think that's goofing it up. The word italic being in there. Curious. Back. Run it again. Huh.
Mine
Seems
looks
to
normal.
show correctly on my end.
It does. So this is
Mhm.
absolutely my PC. Well, there you go. I don't know. Isn't that frustrating? Isn't that why you need persistence as a data analyst? Anyway, but then you can put code in a markdown cell. You just got to put these 3 tick marks, which are in the upper left corner of your keyboard. So yeah, I don't want to. You'll see lots and lots of Markdown. You don't necessarily need to be fluent with it, but it may be something useful where you work, where your folks want to see a nice looking Jupyter notebook to accompany a monthly report or whatever the case may be. So if you need it, you'll get better at it. I use it because these notebooks are almost like a textbook where I have, my I talk about this the thing we're going to be doing, and then you have a code cell to practice what we talked about in the Markdown cell, almost kind of like an interactive textbook. So there you go. How are we doing? Yeah, a little bit longer. And Python, I didn't it flash of the obvious, I didn't even think of it. But I'd been working with Python for, I don't know, a couple of weeks before I learned that it is named for Monty Python. So that's kind of an inside joke. It's not everywhere, but you do see quite a few Monty Python movie references here and there in different Python tutorials and texts. And so Mike, he's a good guy. He goes with it. What floats in water? Bread, apples, and very small rocks. I think this is maybe from Monty Python and the Holy Grail, where they were, she's a witch. Our chief weapons are fear, surprise, and ruthless efficiency. That might be from The Meaning of Life. I'm not sure. Anyway, these are.
Donald, I have a quick question.
Sure.
And I'm sorry, this late in the game, but when installing Jupyter Lab, did you are we to use Mamba or Conda or Pip? I'll say.
Well, you shouldn't have to do any of that. If you went to the Anaconda link that I emailed you last week,
Okay. Yeah.
before class starts, and
Yeah.
then you run that install package just like any old good old Microsoft installer. It will create this folder, this Anaconda folder, and it will stick these applications in there so that you don't ever have. Conda is a way to go get an additional library or a way to update Python or update your libraries. But if you go and install the Anaconda distribution of this software, you won't have to do any Conda or anything. Not at least not at first.
Okay. Thank you.
Sure. Okay, so yeah, these are markdown cells, and you can stick an image in there, and it embeds in the IPYNB file. So of course you have to be cognizant of file sizes. Okay, so assuming you are following along with me, that's the markdown portion. That's the documentation, the nice, pretty readability part of a Jupyter notebook. And then you'll have code cells. So in this first code cell, I would like for you to write what it says there. And you can cut and paste it, but it's better to it's better to enter it, because you can kind of start to see where Jupyter Notebook starts to do things that are kind of automagic. It sort of formats stuff for you. It tends to put in the second parentheses when you enter something in parentheses, a quote, so it does stuff for you. If you type in something incorrectly, it tends to turn it red, so that you sort of know visually that you've got something strange going on before you ever even execute the cell. It's in there trying to kind of help you write code. So everybody type in print, and you see how it went green. See that? PRINT, boom, green. That means, okay, you've got a Python recognized keyword here that you've typed in correctly. Which, and as you get used to working with these things, there's lots of shortcuts like that. And then the open parenthesis, and you see there, it pops in the close parenthesis, because print is a function that you send parameters to. So it knows that you're gonna need that close parenthesis, or it'll error. So it pops it in there for you, which can be frustrating because you don't always. Sometimes you're trying to you put something in the middle, and you don't want the closed parenthesis where you're typing the open parenthesis. You need it all the way at the end of whatever you're doing. And anyway, some of the auto magic gets to be a little annoying. And then the quote, you can use single or double quotes. Either one will work. And then your string literal comes out in red. And then if you you can hit Control Enter, and it will execute the current cell wherever your whatever cell you have selected. Control Enter is the keyboard shortcut for run, and that print is the the standard output, kind of like a, what is it, C out in C, and something more complicated than I ever really want to deal with in Java. So print is a function that takes any number of inputs. You can do multiple strings, you can do variables and numeric literals. Anyway, and so it'll print more than one thing at a time, but we'll work with that for sure. Okay, everybody got their first their Python Hello World program written? Yay. Now, humor me here, guys. I have very little joy in my life. Is this really their first Python Hello World?
Yes.
Woo! Thank you. Job satisfaction. Yeah, Hello World is everybody's. If you've never been a coder at all before, Hello World is how you make sure that everything is working in whatever language you just installed. So there you go. It's the most basic. You're making your computer say hello to the world. Cute. Okay, so the next cell, type in what we've got here. This is assigning a value to a variable, which we will do until you're sick of it. myvar equals 3 plus 4. So the results of the mathematical operation on the right side of the equal sign are assigned to, it's it's a variable. It's assigned to a variable. Variables can vary. But what myvar really is a memory location. That's a name for a place in memory where you're storing the result of 3 plus 4. And then you can print myvar, no quotes, because you're sending the memory location myvar to the print command. You're not sending the string myvar. Now, if I hit Control Enter, we get 7, right? So if I were to print, and you'll see another notebook ism here, it overwrites. It doesn't add output line after line after line after line after line in these notebooks. It overwrites the output. So every time you run, if you modify a cell and run it, modify a cell and run it, you're only going to see the latest output from that cell. So if I print myvar in quotes, you get Control Enter. It overwrites that 7, which is the value inside of the variable myvar. But if I put it in quotes, Python doesn't even recognize that the string literal mybar has anything to do with the memory location mybar. So it just prints out the string literal. So that's a code cell. Those are code cells. And you can also tell a code cell because it has this this in and this bracket nomenclature next to it. So that's how you can tell. And it's blue instead of, I think it's blue instead of green. Is that right? It's green instead of blue. There you go. Code cells are green, markup cells are blue. Okay, let's we've been at it since 9:35, right? I believe. Yes. So it's been an hour. Let's take 11. It goes to 11 and come back at 10:45, and I'll finish up with what I have to show you, this first tour of Python, and then we'll break for the day. Okay. 10.
Real quick question before we
Sure.
go.
Sure.
Why don't you just make 10 louder?
So, I'm sorry, say that again, Jim.
Why don't you just make 10 louder instead it goes to 11, right?
Oh, thank you. Somebody gets it. I sometimes wonder these Zoom sessions, I can't see anybody smile or frown or roll their eyes, or I never know. So I'm trying to not be an automaton lecturer. You get bored, I get bored, but it goes to 11. You know, most
Goes to
amplifiers only go to 10. Mine goes to 11. All right, 10:45. Pause recording.
Goes to 11. Great. Data science.
Read. Back to my notebook. Okay, so I want to make sure I don't get ahead of myself. I went through this and there's a lot of good information. So when you insert a cell, like let's say we're up here in this code cell, so we can insert cell below and we get a fresh code cell if you need it. And if you wind up not needing it, you can always just click on the scissors and it goes away. But it defaults to a code cell, and you'll see the bracket next to it. If you want to change that, if you want a markdown cell because you're going to type in some information instead of computer code, you just insert cell below and then click in it and drop this down to markdown, and then it changes. You see the thing go away. So that's how you insert and cut cells. Now this is and we'll go over it again, so don't worry about any of this being the only time you're going to hear it. You probably noticed there's these numbers next to the code cell, the in, and then it was 1 up here, and this was 2, and now it's 3. And if I do something again, print 5 times 20, and I run Control Enter, it changes to a 4. So what that number means, and it's only next to a code cell, is that number tells you in what order the cells have been run, because it doesn't matter where they are in order, the code cells. It doesn't matter what order they are in on the notebook. It matters what order you run them in, because unless you specifically tell Jupyter Notebook, run everything from the top, run every code cell, it executes them individually. And there may be times when in a long notebook, you might go down and execute something before you don't do it in sequence. So just to keep something to keep in mind. But I want to make sure I don't want to get too far ahead of myself, because there's whenever you run a code cell, for every notebook, and you can have 1, 2, 3, 4, 5, 6, whatever, however many notebooks open, each one on its own, browser tab. They each have a separate copy of Python running. So anything you do in one notebook will be invisible to the next. So we could have another notebook running where I've made my var equal to 7,000. This notebook doesn't know about that notebook's myvar because each tab is its own independent Python environment. But inside of a Jupyter notebook, every cell you run, if you create something like myvar, it lives on until you close the notebook out. So right, even though we're kind of done running this this code cell, the myvar with the value of 7 assigned to it still exists. So that's why we want you to print. And even down in this code cell, the value that we assigned to myvar is still, in memory, still running in your program. And control and enter. This is myvar 7. So this is an example. This print statement is an example where we are sending it 2 parameters. We're telling it to print this, and then this string literal. This is myvar. So print those exact characters, and then print the contents of the memory location or the variable myvar. So this is myvar. There you go. And then you got 7. Okay. There you go. The statement creating and assigning the value to myvar didn't run in that cell, but it's still available to in any order. Now, like just for example, we created myvar in this cell. I could insert a cell above and print myvar. And even though it's before it physically, it doesn't matter. It doesn't matter. It's the number, the sequence in which they're executed. So get rid of that little thing. Okay, so that's how that works. What you do in any code cell affects every other code cell, no matter when the execution happens. There you go. So once you run some code in a Jupyter notebook, it doesn't matter where it's at on the page. It's affecting the Python environment. Okay, so you gotta auto save here every 120 seconds. But if you want to close out and it's been less than 2 minutes, you can always hit this floppy here and it'll create what it calls a checkpoint, but it's saved. So floppy is save, just in case something crashes. It's always good, to save early and save often. Don't do it yet, but the elegant way to close down both the Jupyter notebook, the Chrome tab itself, and the underlying Python interpreter environment is to say file, close, and halt. So what that will do is close the tab and halt the terminal session, the Python interpreter session. Sometimes the close doesn't work, and I haven't come to the bottom of exactly why that is, but sometimes I'll hit close and halt and the tab won't go away, and other times it will. So there you go. You can also do things under the view menu to change the appearance, and I encourage you to goof with any of this stuff, and we will. By the time we're done with this course, you'll be a Jupyter notebook whiz. There are other things you can do. The like I said, the program running in the background, this thing down here, is your kernel. And you sometimes, if if you write the wrong software and it gets confused, you need to shut things down. So there are commands from the kernel menu here that can do all that. Generally speaking, I don't mess with that. Generally speaking, but it could be where you need to work with those sorts of things. And then the cell menu, as you get more and more advanced, you may want to run everything, run all above where your cursor is sitting, run all below where your cursor is sitting. There's also all these outputs, like if you get sick of looking at at this, or you get an error, and some of these error messages can just scroll down your screen. You can say all output clear or current output clear. Like, I believe current output clear is just going to get rid of that 100, but it's going to leave this is my bar 7. It'll leave that alone. Current output clear. Yeah, that's just the output of the current cell. It just clears that out of the way. And like I say, if you do something wrong, let me do something wrong. Let me print 5 times 20 and see what happens. Boom. An error. And that's a very simple, name print is not defined. But these error messages, when you do something wrong, can be a couple pages long or more. And not always the easiest thing to interpret. But if you don't want to look at that anymore, you just say cell current output clear. So that's dealing with that and dealing with cells. And then, scroll down here, just good programming. And this, again, Mike teaches intro to programming to undergraduates at UCA. But I left this in because I think it's good to know for yourself. As a programmer, writing computer code, like I know they use Python to extend Domo at CAE. I know there's I've been helping other guys write stuff that automates processes. So it could be that you find yourself writing computer programs, and very quickly you can fall victim to poor practices. So here's 8 good rules. Good program is an essay on problem solving written for humans. I mean, that's why they make the programming language so understandable, is so that humans can read it and understand. But it just happens to be in a strict enough format that you can do something with it on the computer. It's always good to think about what you're writing. Here in 3-4 weeks, you'll know enough Python to start doing some brain teasers. And you're going to want to kind of think about solving the problem before you start writing code, because there's something about writing code. Once you've written it, your brain wants to save it. Your brain doesn't want to delete that code. It may not work. It may not be what you really needed to do, but I wrote it, I want to keep it. So planning designing what you're going to write before you write it, even if it's only 20 lines of code, is always a good practice. And again, becoming a good programmer is like getting to Carnegie Hall. Practice. I try to get into Python at least weekly, so I don't completely go cold. But it's tough depending on the demands. The conventions of any programming language are there for a reason. Use them. A convention is just like a loosely agreed upon, sometimes it's tightly, but usually loosely agreed upon rule for how you do something. Like naming variables using an underscore instead of, I don't know, the parenthesis or whatever under words. Conventions can be for a given language. Like there's certain ways to write Java that makes sense to Java programmers. Python kind of has its own thing to, if you get that print statement, if you're sending 30 things to it, sometimes it's good convention to put each on its own line. And you'll see that in SQL as well. So they're there for a reason. It's kind of ways of doing stuff, and naming conventions, those sort of things are good. Yeah, test your code, test it again. Your code should be self-documenting. What's that? What that means is like not using a variable called X, because who in the heck remembers what X is supposed to be? If it's, user last name, the last name of the user, put, user underscore last underscore name. That means that's self-documenting. That means when you read it, you understand what it is you're manipulating, what it is you're assigning to things. But comments, I want to say there's an example of a comment coming up. Hang on. Yeah, we got comments coming up, so you'll see what that means. All all input is evil until proven otherwise. Validate it. The programming exercises we do will be like, get an input from the user for the length of the sides of a rectangle and compute the area, and then print that out to the screen, or something to that effect. If somebody puts, Don for one of the one of the sides of the triangle, it can barf. So that's what we're talking about is validating input. And real, production programmers, application developers do go to enormous lengths. I know I did, to validate data coming into the program to avoid future errors or any future problems. And like I said, we won't get into that so much, but if you do write something for someone else's use, making it as idiot proof, making it as error proof as possible on input is worth, some of your time. A function should only do one thing. I beg your pardon. We will get to that in a future lesson, but what that's talking about is making code modular so that you can understand what this chunk of code is doing, and we'll learn how those chunks are created using a thing called the function. I will continuously borrow you with reference to these rules all semester. I guess I should delete that part because it isn't a semester. There's a link to the Python language standard. Now, this next block is true. There are really only 3 types of statements in a computer program. And if you've learned a little tiny bit about programming, it can seem kind of overwhelming. But when you keep this in mind, it sort of, to me, takes a little bit of the intimidation out. But it's like, I can't remember, is it Go or Mahjong or one of those games? It's a moment to learn, a lifetime to master. These 3 types of statements can be combined such that it gets complex. But these 3 types are sequential, which just means the computer, goes line by line by line by line by line and executes each one without any thought. It executes each line of code one time and then moves on. That's like what we had up here. This, we have an assignment statement, and then and then a print statement. These are sequential statements. They just do one thing, and then the computer goes to the next line and does the next one. And then there's decision, and we'll learn how Python does decisions. That's where you've heard of if then else logic. If this is true, then do this. Else, if this is true, do something else. Do another else. Else, if this third thing is true, do something else. And then there's like a otherwise, and if none of that's true, do this. So those are decisions, and the computer will go through that one time, and you'll see there are branches based on that decision logic. If it should do the following line or lines of code. So we'll learn all about it's a if elif else if in Python. There's every language does them slightly different, and you just got to learn the syntax. And once you get rolling with it, it's not too tough. You just kind of got to learn how to play computer in your head when you're reading through your own code. You just you become the Python interpreter, and you have to decide, exactly what this thing is going to do when it actually executes. And then you have repetition, also called looping, and this is used a lot. That repeats a line of code or lines of code either a certain number of times or until a condition is met. So that you can, like do while something is true. You might have heard that term. So we will have lots of practice in all three of these types of statements. And guys, I do apologize. I'm probably gonna get ahead of myself when I'm explaining something that if I was just reading a script, I would stay on track, but better to hear it more than once than to not hear it at all. So these are some basic Python commands and features. We've done this again, or done this one before, but here, check these out. # space, and then whatever you want to say about the code that you're writing. And this is where you can explain why you're doing what you're doing, so that you understand what you've written later when you come back to it. But it's ignored. The # in the first space of a line will ignore anything else on that line, so you won't get an error or whatever. Empty lines are ignored, and so they don't cost you anything. So if putting spacing between chunks of stuff, almost like paragraph structure in English, if that makes sense, if it makes it more readable, please do. You can, as I said, you can use single quotes or double quotes. I don't believe you can mix and match them. But let's test that theory here in just a sec. So we're doing hello again in single quotes, and then single quotes. That just prints a blank line. If for whatever reason print nothing, we'll stick in a blank line. And sometimes you need that in your output, or you want it. So let's click in here and say Control Enter, and it'll say hello again in a blank line, and here's another line. But I wanted to rerun this and try and remember my theory. If it seems like you can't mix and match single and double quotes, but let's try that. If howdy prints, then I'm wrong. Boom. Yeah, it sees that first single quote before howdy, and it's looking for another single quote to close out that string literal. So there you go. Like I thought. Hello again. Here's another line. Okay. As we were saying, that like for that my underscore var, variables are names that represent a location in memory. You should think of them as a named container for what you want to put in your program. Think of it like almost like a label. Now, those of you who have never worked in Python before, like I had not. I had worked in C and I had worked in Pascal quite a bit and in Ada and DBase3 and a few other languages like that. But I'd never worked in Python. And the first Python class I sat in, it was Dr. Ellis, Mike Ellis starts using variables like myvar. And I'm like, what? What are you talking about? Because in previous generations of programming languages, you would have to have a line of code that would declare like myvar, and you would have to tell the program, it's called myvar and it's a number, and then that's all you can put in it. If you try and assign, ABC to a number variable, it chokes. Python is much more flexible, and you can within your code you can assign a variable and give it a value, and it goes okay, and it just guesses what the data type of the variable should be. It's called dynamic typing instead of static typing. And like I said, if you're a hardcore C++ Java programmer, that is unsettling. And it is something to contend with, because sometimes it guesses differently than you might necessarily assume, but it gets to be where you understand the rules of what happens when you just start using a variable. Using a variable name declares the variable, just like we saw with myvar up there. There are naming conventions in every language. They can differ within languages depending on who is setting them. Use the most popular standard unless your boss wants you to use something else. Yeah, and you're going to see that in larger development shops. There will be coding standards for how to name things, how to do comment blocks, how to document an entire section of code. For us, we'll use lowercase letters. And if it's multiple word, use an underscore. Now there's another naming convention called camel case, where you capitalize the first letter of every word. So it just depends on what your shop wants to do, what your organization wants to do. But for class, if you would do things like this sales tax amount, I'd appreciate it. That way I can keep track. And then we're now back to assigning variable names, choosing variable names. Sales tax amount. Okay, that's a good name. Sales tax rate would be like a percentage. That's a meaningful name. Tax, you don't know. Is that income tax, sales tax? Just as an example. So there's no penalty for a long variable name. You don't want to go too far, in an extreme like that, because it can take up a lot of screen real estate. But like I said, a variable X, not good. So yeah, meaningful variable names. And then here is an assignment statement. Absolutely horrible name. Never do this. There you go. Meaningful variable names. That way you know what you were doing. I know what you're doing if I'm helping to troubleshoot something. And this is another sequential statement that takes the result of sales tax amount times tax divided by 100 plus this X thing, and puts that in a variable called sale total. Now, this is something that Python can do, and it's short syntax, but I don't do it, and that is this type of variable name alone, and Python will display its value. Python just assumes, like let me insert a cell above, because this might get a little confusing. Oop, did I say below? All right, good enough. If I just type myvar all by itself on a line of code and execute it, Control Enter, it defaults to printing the value of that variable. But it overwrites it. If you just did that, every line in the cell would overwrite the next line, and you wouldn't see all of your output. But if you put them in individual print statements, they will go on the next line. Print defaults to adding a new line character. So let's get rid of that. Doing okay for time here. Run this one. Okay, so sales tax amount by itself is responsible for this 8.41, but then this output is the output of the print statement. So anyway, I put everything in its own print statement. I'm gonna just, as a matter of convention. I don't know that there's no advantage other than it's a shortcut to do that thing where you just put the variable name down there and it goes to output. So I mean, if you're experienced with Python, let me execute that with individual print statements. Yeah, see, it buries one of them because the print overwrites the output. Anyway, it's confusing to me. So I put everything in its own individual print statement, because there's never a time I don't want to see, you know what I mean? The variable or whatever. So I always just use individual print statements. So there you go. I recommend you do too. And then I wanted to talk about the concept of data types. We addressed that, briefly in the previous PowerPoint. Python is dynamically typed. It will guess the data type, and there's several. There's integer, string, float. It will guess the data type, and then depending on what the data type is, it will. There's certain things you can't do. You can't do mathematical functions with a string, say the character string, and vice versa. Numbers will print differently than strings. There are string methods you can do that will barf. But then, if you know other programming languages, you can convert the data type of a Python variable just by using a conversion function. Like you can put int in front of a string variable and it'll turn it into an integer. It takes some getting used to if you're used to programming languages at all. If you're not, it takes some getting used to for the first time. And so it won't be a change, but it's something that you wouldn't normally have to do with another programming language. Okay, so that's numeric data types. They can't include a dollar, no spaces. That's two different variables, or commas. Oh yeah, yeah. And there are formatting strings you can use in your print statement, but we'll get to that a little bit more. Now this is the partial rule for what I was talking about, where it assumes the data type of a variable. If you say it's equal to a number with no decimal, it assumes it's an integer data type. If you say like myvar equals 4.0 with a decimal point, it assumes it's what's called a floating point, which is a numeric variable that allows decimal places. So it can be important which data type a variable is can be important for some operations. Yeah, there are times when you're trying to do something, and if the variable type is wrong, you'll get an error message. So it's good to know what you're dealing with. So that's numeric data types. String data types are literally a string of characters. So first name Arthur, King of the Britons, I am your sovereign. And this will print. And if you run that one, you'll see that it puts a space. There is no space after Arthur or before King, right? But there's a space right here. Well, the print command stuck that space in there. It just assumed you wanted a space. So we'll show you how to avoid that if you don't want that space. And then of course we can do math just like you can in Excel or anything else. The exponentiation character is 2 asterisks. Multiplication, division, and I think that's modulus, remainder, are the usual characters. You know, star for multiplication, slash for division, and it seemed like percent is mod. And then addition and subtraction are the plus sign and minus sign. So you can do, you know, these numerics, or you can do math on numeric data types, just like you would think, just like normal, as we've kind of seen with the myvar is 3 plus 4. Parentheses, I use them even though you can count on the order of operations. You know that we do division, multiplication first, and addition, subtraction. You know, I count on I can never remember that or trust it. And for readability's sake, I put parentheses in mathematical operations anyway. So there you go. Now, here's what I was talking about a minute ago, converting sales tax amount we declared up here in this cell. And it's 8.41, which is a floating point data type. So the data type of sales tax amount is float. And if you print it, you'll see that it prints with a certain format. And then I'm not sure why I'm printing it 3 times here. Oh, it's just to show you that it doesn't actually, it doesn't actually convert it. So this first print statement will print a floating point variable. The next line prints the integer portion of it, or a temporarily converted to integer. So it'll be just 8 instead of 8.41. But then we printed a third time to show you that it didn't actually convert it to that integer portion. It was temporary just for the print statement. So there you go. Long story for a simple explanation. But if you wanted to permanently convert sales tax amount to an integer, you could say sales tax amount equals int sales tax amount, and it would change it. So there you go. Now, this is like what I was talking about, the order of operations. If you look at that, maybe Hunter, maybe you're you're a resident mathematician. Maybe you look at that and go, oh yeah, yeah, got it. Well, I look at that. I look at that and I'm like, which one is what? What do you do first? So, human nature is to do it completely left to right. But that will mess it up because that's not the way order of operations works. So I would put things in parentheses if you're doing math in Python. So we're supposed to guess what that equals. Have you already run it, or can you guess?
I ran it, but I don't know if I should.
That's okay. There's no penalty for for sneaking ahead. So yeah, last class we did this, and I was thinking it was like 18. Pretty sure it's 12. But then you've got some other print statements here, like print 16 divided by 4. Pretty sure that's going to be an integer, and we'll see here what it assumes the result of a multiplication is like that. Is that 4 or is it a float of 4.0? Let's see. So it is 12, and it does it assume, even though that's an integer number, even though temp int is 4, it Python assumes it's a float and makes it 4.0, which like I said, Python just assuming the data type is completely counterintuitive to an old school programmer. But there you go. But if we wanted to change that, we could say, I believe we'll soon find this out. Temp int equals int of temp int, and then print the type. Type is a function. You send it a variable and it tells you the data type of that variable. And we'll be using these things all day long. And then we print, I guess I could have cut and pasted that line up there. And then we print the type of temp int after I made it equal to an integer. There you go. So you can, yeah, it's crazy, right? Any of you guys with me, you old school programmers? Is this dynamic typing that you've seen the first time? Anybody with me, or am I all alone with dynamic typing?
Trying to get mine to
We're
work.
here.
Yeah, it's kind of nuts, and it can change it, and then if you flip it back the other direction, you've lost something. Like if you go from 4.13564 convert it to an integer, the 0.13564 will be missing if you go to convert it back to float. So it's something you just gotta kind of get used to. But it matters as you are doing things with either a floating point number or an integer or a string or some of the more complex data types. What you're trying to do with them matters as far as what data type they are. So here's a little example. So we've got 3 integer variables here: selling price, variable cost, and then fixed cost. That's your break-even formula, basic break-even variables, variable cost per item, and then break-even quantities, fixed cost, and then we're using 2. I'm trying to remember what that is. With no with no remainder. That's what it is. Break-even quantity is 40. So there's your typical mathematical calculation in a Python cell. And you could tell it's an integer data type because it prints out without any decimal points. And then, like we said before, remember the comma in a print statement with 2 string variables, 2 strings, will insert a space, but quite often you might not want that there. So here's a chance to type in some, so we've got first name and title, remember, were the variable names before. So what would you have to put in that code cell to make the output exactly Arthur, King of the Britons? So we don't want to use commas because that would inject a space where we don't want it. So what we would do is say first name and then a plus sign, which is not it's okay to add string variables like this because it defaults to making that a concatenation of the strings as opposed to trying to mathematically add them together. So we would say first name, and then we want a comma and a space, right? And then we would, and then we want to concatenate title. I believe that's right. First name plus comma space plus title. Arthur, King of the Britons. Arthur, King of the Britons. There you go. Okay, getting down towards the end here, guys, and I'm going to let you go for the day, and I'll show you that assignment real quick before we go. So that's just some basic Python. I'll go back and we'll do math, and we'll do much more with strings, and there's other data types, and then we got to learn all about these, you know, decision types of statements and loops, and once you get all of that kind of a foundation of the basic Python language, then we can show the real magic, which is really the analytical libraries. But you got to know the basic Python first, or you can't get there. So that's why I try and cover it start to finish, you know, from the first week. So those are just some examples. If you're having trouble getting anything installed, you got any other questions? My cell is in my signature block in my email. So you're welcome to shoot me a text or call or shoot me an email. And here's some you're gonna I hope I like Mike. He's a good guy. Quick message from Captain Obvious. Variables can vary. So like I said, the variable name is really a memory location, and you can always change what's in the memory location. But sometimes we want a constant, which this is getting to be kind of like a really is software engineering best practices. So if you have a magic number that you don't want other programmers messing with by accident, and you want it to be really readable, put that in all caps. And it's good, instead of using 0.0885 throughout your program, if you've got a magic number, it's good to assign it once so that if it changes, like sales tax rate or whatever the case may be, your employee bonus percentage, whatever, create that numeric constant one place, and that way you only have to change the number one place in all of your code, instead of going around looking for 0.885s everywhere, which you may have that somewhere. It might be 0.5. Well, you could have 0.5 all over your program. You don't want to mess with that. So if you've got some sort of a number that is important, it's best to store it in all caps as a constant. Now you can change that. There's nothing to keep you from doing it. It's a matter of readability and convention. So I will pass that on. One last programming example. Oh yeah, here's some more math. Got a couple of floating points, a couple of integers. And then, Mike, this quantity and cover price. Hate it. Anyway, let's run this. See the print statement is the one that said total disorder, but then is 15 the quantity or the price? When you just type the variable name, it overwrites the output. So like, let's put one more. Let's do my bar. Pretty sure. Let's see. We'll experiment here. That it's just going to show like 7 at the. Yeah. So when you do just the variable name, it overwrites it. So I would just, if that looks cool or if you're used to it, okay, but I would recommend you actually type in a print statement if you want to print what is inside the variable quantity, for example. Okay. Any questions on that? Knowing that we'll go over all this again. Okay. To close out, remember to close out a notebook. I always hit the floppy one more time, save and checkpoint, and then you come up here and you say file, close and halt, and that will close down the Python environment and close out the tab. And like I said, it doesn't always work. I don't know why, but sometimes it doesn't close out that tab. But once you have hit close and halt, your code cells will all be stupid because there's no Python for it to talk to anymore. So you might as well just close the tab manually if that ever comes up. Okay, and then from inside the browser menu or the Explorer menu, you just click on quit. And you see the server stop. That means we've shut down that terminal session that is making our Jupyter Notebook smart. So now this tab is relatively stupid. So you just close it out manually after you have said quit on the Explorer menu. Okay, so for the rest of the class period, or if you're going to lunch, whatever, at some point between now and you go home Friday afternoon, if you would take a look at this assignment here, business analytics problems. And I've already described it. There's the instructions. Just type up a Word document. Let me know what you're working with, what you're working on, challenges. You can't give me too much information. I'm morbidly curious about everything. So, and guys, I put 10 points, but this class is pass fail. You stay with me, and you don't just completely throw your arms up and quit. We'll all get through this. Realizing that some folks come in with like absolutely no computer programming experience whatsoever, or in some cases no analytics experience, and others are already semi gurus, just polishing up on a couple of things or getting a refresher. It's absolutely pass fail. I put 10 points on there. I generally, if I get an assignment, and this goes for SQL programming challenges and Python programming challenges and whatnot. If you upload something, I'll give you a 10 unless we both agree that you didn't get everything done, and I'll make it a 9 just so that I can kind of see as I go through these quizzes that you kind of been struggling a little bit, and I can just to keep my mind up. But don't read anything into the number of points. Any questions about anything before we reconvene on Tuesday morning at 8:30?
The only question I have is, will you upload the recording to the Canvas classroom, or will it be emailed to us?
I'll upload a link to the session in the classroom under, I'll put it right. I tried to do the Tuesdays and it wouldn't cooperate with me. And those were bad recordings anyway, but I tried to smush them together and upload it, and it wouldn't cooperate with me. Let me go to, where are they? Modules. There you go. I'll upload them here under session recordings.
Okay.
And yep, I'll get this one loaded later today, since we had perfect audio and no internet interruptions.
Yes, we did.
Okay. Awesome. That was so embarrassing yesterday or Tuesday. Hey man, it stresses me out.
Ethernet is the
Been
best.
there.
There you go. Okay, guys. Have a good weekend. I'll see you Tuesday morning at 8:30.
See you
All
later.
right.
Bye.
Bye-bye.
Have a good weekend.
Good weekend, guys.